Hi there, I'm Mrs. Burns and welcome to our first lecture of our chemistry unit. This will be covering the beginning of chapter 4 and you can read along in your textbook from pages 168 to 173. Additionally, I advise you to take some notes on this lecture as we dive into atoms and the periodic table. So here are the big ideas of the lecture, the things that I want you to walk away understanding, and these are that an atom is the smallest particle of any element, that atoms are made up of protons, neutrons, and electrons, and finally that these elements that we'll be talking about can be arranged in what scientists call the periodic table. Here are some words that I'd like you to know and not just memorize, but also understand how do these words work together and can you display your learning of these words, for example, in a diagram or a picture. So all of these words on the screen we will be talking about today. The first one, atoms. So atoms are very super small particles, and you can only see them on something called an oscilloscope, and you have to have a special laser called a femtosecond laser. And what you'll find is that there are 50 million atoms across the length of simply 1 centimeter. That's a lot of atoms packed in. Your textbook has a really great analogy of an ice rink to help put the femtosecond into perspective. So that would be on page 168. So an atom is the basic unit of an element, which we've said, and 2 or more atoms can come together to make a compound, and a group of atoms sharing electrons makes up a molecule. So notice here we have 3 terms, elements, compounds, and molecules. You do need to understand the difference between those. And I would like to note that these are elements and compounds are pure substances. So elements cannot be broken down chemically to become any simpler, and compounds are just 2 or more atoms specifically combined. So our atomic theory. This theory states that atoms are made up of protons, which are positive, neutrons, which are neutral, and electrons, which are negative. So you can see in this picture where we have our protons, the blue circles, we have the neutrons, the red circles, and we have the electrons, the green circles. You might already notice their orientation. The protons and neutrons are together packed really tight right in the middle of the atom, and in that area we call the nucleus, and then the electrons are more spread out broad around the outside, and they form these different layers called shells, and the electrons form the bulk of the atom. All atoms are neutral, and that means that they have the same amount of protons as they have electrons. So the number of positive ions and the number of negative ions are the same, making it have no net ionic charge. Another thing about our atomic theory is that nuclear charge is a term that we use to explain the charge on the nucleus. And we know that the nucleus is made of protons and neutrons packed together really tightly. And now because they're all packed together really tightly in our nucleus, we see that all the electrons are on the outside, and so the only charge that is contributing to the nucleus are the protons. Therefore, the nuclear charge is really just the number of protons that there are. So in this case, there are 1, 2, 3, 4, so the nuclear charge would be 4. And the atomic number is another way of expressing this nuclear charge, and that is just the number of protons. And because atoms have a 0 net charge to them, the number of protons and electrons are equal, then the number of protons equals the number of electrons, and this is another way of saying the nuclear charge. Here is a table that you can find in your textbook on page 170, and it's a great summary of the differences between protons, neutrons, and electrons. A couple things I'd like to note is that the protons and neutrons are both found in the nucleus, whereas the electrons are found outside the nucleus. And the mass of the protons and neutrons are very similar. Now this is the relative mass, and that's why we don't have any units here. So relative to each other, the protons and neutrons are really, really similar, but then you can see that the electrons are way lower in mass. So this is something that you will want to take note of. Additionally, we express the protons and electrons having a charge as so. This periodic table is a wonderful way for scientists to classify the known elements. You can find this table on page 172 of your Science 10 textbook, as well as in the data booklet that I've given you. So this periodic table is organized. The whole left side of the table, and these are all metals. And on the right side are all the non-metals. And then the metalloids are these guys who form the staircase in between. So it's important to know which elements are metals and which ones are non-metals because they will react differently. So sometimes an atom, we remember that has all of the electrons around it in its shell. So here, these little dots are the electrons around this atom's shell. And sometimes an atom will lose one of those electrons, or sometimes it will gain one of those electrons. So many metals fit under the category of losing electrons, and we call those cations. So again, cations are usually metal elements that like to get rid of their electrons. So when you get rid of the negative electrons, you end up becoming a little bit positive. Multivalent elements also like to lose electrons. However, sometimes they lose more than other times. So these also end up positive. But for example, iron can sometimes end up being +3 and sometimes can end up being +2, whether it gives away 3 or 2 of its electrons. And finally, many of the nonmetals like to gain the electrons. They like to take the electrons from those metals, and we call them anions. If they're gaining the electrons or getting more of those negative electrons, they become more negative. So you might be wondering why, Mrs. Burns, why do we have ions? Why don't the atoms just stick to themselves? Why are they gaining and losing electrons? Well, we're going to talk about tomorrow about the different shells of electrons, and the outermost shell, called the valence shell, likes to be stable. So the electrons will be lost or gained in order to keep a stable outer shell. Here are some examples. Aluminum here is a cation. It likes to lose its electrons, and it's going to lose actually 3 electrons and end up with a +3 ionic charge. And then iron, which we already talked about, is multivalent. It also likes to lose electrons, and in this case of +3, it would lose 3, or maybe it will only lose 2 sometimes. And finally, chlorine, this is an anion, and this will gain electrons. So because it's gained 1 electron, we show 1 extra negative here. So there you go. That is our introduction on atoms and the periodic table. Please read this section of your textbook and come prepared with lots of questions tomorrow as we dive into Bohr models.